Hello everyone, I'm gonna start tutorial 4. The main goal for this tutorial uh, is to investigate first uh, Thevenin and Norton theory, and second investigate Mach's power for any circuit. First of all, let me explain about this theory. If we have network circuit, any network circuit, and here input and here output, and also here resistor like R, and this is terminal A and this is terminal B. This theory says we can simplify any circuit in terminal A and terminal B like this. We can simplify any circuit to a simple circuit which contains of two important elements, VTH and RTH. This circuit calls Thevenin circuits. And also we can change this voltage source to current source like this. This is RTH, and this current, which calls I Norton or IN, and is equal to VTH over RTH. And also here again we have A and B. This circuit is called Norton equivalent circuit. Uh, that's why important key to Thevenin-Norton theory is to find RTH and VTH, or RTH or IN. That's why this theory is very important. Because we can simplify any circuit to a simple circuit like this or like this. The first question describes this story. Question 1. In this question, we want to find out RTH and VTH in terminals A and B. The circuit is like this. We have 10 volts here and 5 ohms here, 15 ohms here, and 10 ohms here, 5 volts here, and we have a resistor here, and the value of this resistor is not important, and here we have A and here we have B. We want to find out equivalent Thevenin circuit across of these resistors and or in terminals A and B. Okay. Uh, That's why we can say uh, this theory says if we have R here and A and B here, this circuit should be simplified to simple circuit like this, RTH and VTH. Now we want to find out RTH and VTH for this circuit. For VTH, important key is to find out and to understand this concept. VTH is equal to open circuit voltage across of resistor R, or uh, open circuit voltage in terminal A and terminal B. In order to find out open circuit voltage or Thevenin voltage, we should change R to open circuit. That's why the circuit should be like this. We have 10 here, 5 here, 15 here, 10 here, and 5 here, and we have open circuit here. This is open circuit. We want to find out open circuit voltage, which is equal to Thevenin voltage or VTH. Okay, important note. This current should be zero. Why? Because this current is zero. That's why we can say 5 and 15s are threes. 5 ohms and 15s are threes, and immediately we can find out this current I. I, for using Ohm's law, is equal to 10 over 5 plus 15, and is equal to 10 over 20 as equal to 0.5. In order to find out open circuit voltage or Thevenin voltage, always we should apply KVL in the loop including open circuit. In order to apply KVL in this loop, for example loop A, we should investigate positive and negative for any resistors. Positive and negative here, positive and negative here, and positive and negative here. And now we want to start with applying KVL in loop A. KVL in loop A says we have minus 15 times I is equal to 0.5, which obtained in previous part, and plus 10 times 0. Be careful, the current for 10 is 0, and plus 5, and finally plus open circuit voltage is equal to 0. And we can find out open circuit voltage, which is equal to Thevenin voltage, is equal to 2.5 volts. This is answer for Thevenin voltage. To summarize, in order to find out open circuit voltage or Thevenin voltage, we should apply KVL in a loop which contains of open circuit. Okay, now we want to find out RTH. RTH is equal to R equal. In order to find out RTH, we should change all of the voltage source. We should change all of the voltage source to short circuit and all of the current source to open circuit. This is important key to apply this theory to any circuit. Again, in order to find out equivalent resistance or Thevenin resistance, we should be zero all of the source, which means we should change voltage source to short circuit and current source to open circuit. For this circuit, uh, 10 volts should be zero and should be short circuit. And here we have 5 and 15. And here we have 10 and 5 volts again should be zero or short circuit. Equivalent resistance or Thevenin resistance is obtained in these terminals, terminal A and terminal B. And immediately you can investigate 5 and 15 are parallel and total should be 3 to 10. That's why RTH is equal to 5 parallel to 15 and plus 10 is equal to 30.75 ohms. That's why VTH is equal to 2.5 and RTH is equal to 13.75. To summarize, uh, this theory contains of two steps. Step 1 for defining Thevenin voltage, step 2 for defining equivalent resistance or Thevenin resistance. For Thevenin voltage, we should consider open circuit instead of uh, terminals, which we want to find out equivalent circuit. And for equivalent resistance, we should change all of the voltage source to current and to short circuit and all of the current to open circuit. Once again, in order to find out equivalent resistance or Thevenin resistance, we should change all of the voltage source to short circuit and all of the current source to open circuit. Next question, again, discuss about this technique. Question 2. Question 2. In this question again, we want to find out VTH and RTH for terminal A and for terminal A and B. For this circuit, we have 0.8 amps and 10 ohms here and 10 ohms here and 5 ohms here and 16 ohms here And also we have a current 1 amps here. Here we have terminal A, and here we have terminal B. And also in the special case here, maybe we have a resistor like R. In this question, we want to find out VTH and RTH in terminals A and B. Okay, again, we want to start with determining VTH, which is equal to open circuit voltage. We can use source transformation in this circuit. For example, it's up to you. We can use and we can start directly. Right now, I want to use source transformation to change this current source to voltage source, which means here we have 10 and this current 0.8 times 10 is equal to 8 volts. I'm changing this current to voltage source. And we have 10 ohms here and 5 ohms here and 16 ohms here, and also we have 1 amps here. And here we have terminal A and terminal B. The final goal for this part is to find out open circuit voltage or Thevenin voltage here. In order to find out Thevenin voltage, again, the key is to apply KVL in this loop. For example, loop A. In order to apply KVL in loop A, we need this current. And that's why before applying KVL in the output loop, we should determine this current. In order to determine this current, be careful here. The current is 1, and if we define this current, for example, I, this current should be I plus 1. An important note happens in this node. Here, current is 1. Why? Because this one contains this current. And also this current is 0. I plus 1 applied in this node and 1 amp divided. That's why the current here should be I. Again, we have 1 amp here. We defined this I. KCL says this current is I plus 1. And we have 1 amp here. That's why the current here should be I. We have We have positive and negative here, positive and negative here, positive and negative here. If we apply a KVL here, immediately we can find out I. KVL in this loop, for example, loop B, KVL in loop B says minus 8 plus 10 times I plus this 10 times I plus 1 plus 5 times I is equal to 0. That's why we can find out I. I is equal to 0.08. This is a mandatory part before we want to apply KVL in loop A. Now we are ready to apply KVL in loop B. KVL says minus 5 times I 0.08 plus 16 times I plus open circuit voltage is equal to 0. Once again, we applied KVL in loop A. KVL in loop A says minus 5, this minus 5 times I plus 16, this 16 times 1 plus open circuit voltage is equal to 0. That's why open circuit voltage is equal to minus 16.4. This is answer for open circuit voltage. Now I'm going to find out RTH. This is second part for this story. For RTH or equivalent resistance, we should change all of the voltage source with short circuit and all of the current source to open circuit. The circuit should be simplified like this. We have 10 here, an open circuit instead of 0.8 amps, and we have 10 ohms here and 16 ohms here and 5 ohms here, an open circuit instead of 1 amps, and we want to find out equivalent resistance here. The circuit should be simplified like this. We have 10 here, 10 here, 5 here, and 16 here. That's why equivalent resistance or Thevenin resistance is equal to 10 plus 10, this 10 and this 10 series, 20, parallel to 5, series to 16. The total is equal to 20 ohms. This is final answer for equivalent resistance. That's why again we can simplify the circuit to this circuit. This is R, this is A, and this is B. This is RTH is equal to 20 ohm, and this is VTH, which we found minus 16.4. And if we want to find out, for example, this current, immediately we can use Ohm's law and find out this. Next question, again, support supports this technique, and also investigate how we can find out um, max or maximum power for each circuit. Okay, in this question 3, we want to find out max power in terminals A and B, which means we want to find out um maximum power which transfers in terminals A and B. The circuit is like this. We have terminal A here, terminal B here, and also 20 ohms, 90 ohms, 80 ohms, and 10 ohms. And we have 40 volts here, positive here and negative here. In order to find out max power for any circuit, we should find out equivalent Thevenin circuit, or we should find out RTH or VTH. That's why in this circuit we want to find out VTH or open circuit voltage, and next RTH or equivalent resistance. In order to find out open circuit voltage here, important note, the current here is 0. That's why we can investigate uh, 80 and 20 are series, and we can use immediately divided voltage rule. If we define here, for example, node N, we can find out uh, voltage for AN. VAN is equal to total voltage is 40 divided 80 plus 20 times 20. This voltage is equal to 80. And we have same scenario for B. VBN is equal to, again, total voltage divided 90 plus 10, because 90 and 10 are series. 90 plus 10 times 90, and is equal to 36 volts and volts. That's why immediately we can say open circuit voltage or Thevenin voltage is equal to VAN minus VBN, and is equal to 28 volts. Okay, to summarize, um, in order to find out max power for any circuit, we should find out Thevenin voltage and Thevenin resistance for any circuit. And after that, only for using a simple equation, we can find out max power in any circuit. For this circuit, in order to find out open circuit voltage here, we used only divided voltage rule. First of all, we defined voltage here and here, and for using Ohm's law, finally we found equivalent voltage or Thevenin voltage. For RTH or equivalent resistance, we should change voltage source to short circuit like this. We have 80 here, 20 here, short circuit instead of 20 volts, and 10 ohms here and 90 ohms here. And this is equivalent resistance. Regarding description in tutorial 1, immediately we can find out equivalent resistance here because 20 and 80 are parallel, 90 and 10 are parallel, and total are series. That's why our equal is 20 parallel to 80 plus 90 parallel to 10. And final answer is equal to 10 point final answer is equal to 25. Yeah, final answer is equal to 25. And in order to find out max power, we can use this equation. Power in max scenario is equal to VTH square 4 times RTH. This is a simple rule in order to find out max power in any circuit. And for this circuit, max power is equal to 7.84 watt. This is final answer for this question. Okay, next question. Again, investigate this story. Question 4. In this question, we want to find out I1 by using Thevenin theory. By using Thevenin theory. The circuit is like this. We have 60 volts here and we have 10 ohms here, 25 ohms here, 5 ohms here, and 20 ohms here. Also, we have 100 ohms here, and we want to find out this current by Thevenin theory. Okay, important key to solve this question is to investigate Thevenin equivalent circuit across of 100 ohms. I mean, if here we have 100 ohms, we can simplify circuit to this circuit, RTH and VTH. And finally, for applying only Ohm's law, we can find out this current. This current, which is current for 100 ohms, is equal to Thevenin voltage divided Thevenin resistance plus 100. Again, in order to find out this current, which discussed about in question, we should find out VTH and RTH. If we can find RTH and VTH, immediately for using this equation, we can find out the current for 100 ohms. Now, we want to find out VTH or Thevenin voltage for this circuit, and later on for RTH or equivalent resistance. In order to find out VTH, we should open 100 ohms like this. We have 60 volts here and 10 ohms here and 25 ohms here, and open circuit here, and open circuit voltage here, and 20 ohms here and 5 ohms here. Once again, important key, because we want to find out equivalent Thevenin circuit across of 100 ohms, we should change 100 ohms to open circuits like this, and after that calculate open circuit voltage or Thevenin voltage. Now we want to find out open circuit voltage in this circuit. Again, if we define here N for this node, we can find out immediately, and here we have A and here we have B. We can immediately find out VAB or open circuit voltage. Same scenario happens here. 10 ohms and 20 ohms are series, and this 25 and this 5 again are series. That's why immediately we can find out VA is equal to total voltage 16 plus 10 plus 20 times 20. This is voltage for terminal A is equal to 40. And same scenario for B. VB is equal to again total voltage 60 divided 25 plus 5 times 5. Be careful. Uh, for this, we are applying divided voltage in this line, and for this equation we applied divided voltage rule in this line, and VB is equal to 10, and immediately we can find out VAB is equal to V open circuit and is equal to VTH is equal to 30 volt. This is final answers for Thevenin voltage. And for equivalent resistance or Thevenin resistance, uh, we have this scenario. We should change 60 volt to short circuit for equivalent resistance or Thevenin resistance. The circuit should be simplified like this. Here, short circuit, we have short circuit instead of 60 volts, and here we have 10, here we have 20, and here we have 25, and here we have 5. And we are calculating equivalent resistance here. Immediately you can investigate uh, this 10 ohms and this 20 ohms are parallel, and this 20 ohms and this 5 ohms again are parallel, and total should be series together like this. We have 20 here, 10 here, and 25 here, and 5 here. And we are finding equivalent resistance here. Equivalent resistance is equal to 20 parallel to 10 plus 25 parallel to 5 and is equal to 10.83 ohms. This is final answer for equivalent resistance or RTH. Now we are ready to find out I. Here we have 100 ohms. Here we have 10.83 ohms. And here we have VTH is equal to 30 volts. This is VTH and this is RTH. And final goal was this current I. Immediately we can say this current is equal to this voltage 30 divided this resistor and this resistor which connected together series, 10.83 plus 100. This is final answer for current. And this was one way of interpreting to think about Thevenin theory. And also you can solve this question by other techniques and compare your answer for this answer.